Hi guys, today we'll be covering section 2.7. We're graphing again, but in this case we're graphing something called intercept form. Intercept form for a quadratic is basically factored form. It has the a value out in front, so that tells us if it's stretched, compressed, reflected, and then we have x minus p times x minus q, where p and q are your two x-intercepts. So that's the point P0 and Q0. And it's always minus in that equation, or it's just the opposite sign of what the actual value is. So for example here, the intercepts of a quadratic are where they cross the x-axis. And what other names do we use? They are the solutions. And sometimes you hear them called zeros. Okay? So if we want to graph the function y equals 2 times x minus 3 times x plus 1, that would be a positive 3 intercept and a negative 1 intercept. So 3, 0, and negative 1, 0. Okay, so now I'm going to plot those points on my x-axis, positive 3 and negative 1. So those are two of the 3 points that I need when I graph. Okay, the axis of symmetry is directly in the middle of these two. So if I go 1, 2 to the right and 1, 2 to the left, I find out here that my axis of symmetry is at negative or positive 1. So that means the x part of my vertex is 1, and just like we did with standard form, I'm going to plug that in to find the y. So 1 minus 3, 1 plus 1. Now in Desmos, we have 2, 1 minus 3 is negative 8. So I'm going to go out to 1 and then down 1, 2, 3, 4, 5, 6, 7, 8. And there's my graph. Okay, that is a minimum because the a value was positive 2. The domain, as always, is negative infinity to positive infinity, but the range in this case is negative 8 up to positive infinity. Okay, this next one has two factors. We have negative 2x and x minus 4. Now we know this one has an x-intercept or a solution of 4, so that's 4, 0. But this guy, think of that x as just x minus 0. We didn't take anything away from it. So in that case, that would be the point 0, 0. So if you have just an x that's floating outside the parentheses, that guy just stands for an x-intercept of 0. So 0, 0, and 4, 0 have an axis of symmetry directly in between at 2. Okay, so then my vertex has an x value of 2, and I need to find y. Y equals negative 2 times 2 times 2 minus 4. Okay. If you can do that in your head, do it. Negative 2 times 2 times 2 minus 4 is 8. Positive 8. So now I'm going to go up to positive 8. 1, 2, 3, 4, 5, 6, 7, 8. And that is a maximum because our a value is -2. It was reflected. So that creates a maximum. The domain, like always, is -infinity to +infinity. And the range would be all the way down at the bottom, -infinity up to +8. Okay. Number 3 says, draw the graph of a quadratic with an a value of -1 and intercepts at x equals -4 and x equals 2. Okay? Well, so let's think about this. When I write my equation, I know that I have y equals that a value, so -1, x minus p, and x minus q. Okay, now remember that p and q have the opposite signs. So for us to have an x-intercept of -4, that would be +4 in the parentheses. And +2 would be -2 in the parentheses. Okay, so given this information, we can write our equation. Then we can count, right? We are 1, 2, 3, 4, 5, 6 units apart, so we go 3 in either direction. That gets us at -1. So we know our axis of symmetry is -1, so the x value of the vertex is -1. Now we plug that in, equals -1 times -1 plus 4 times -1 minus 2 would be -1 times -1 plus 4 times -1 minus 2 is 9. Okay, now hopefully we can predict that this will be a maximum because our a value was negative, so it was reflected. But we're going to go up. I knew that at the end was 8, so I'll go 1 unit above that to 9. And draw my graph down. Okay, indeed it was a maximum with a domain of -infinity to +infinity and a range -infinity up to +9. Okay, if you have questions, let me know. Here's your exit ticket. Use the notes we just did to help you graph in intercept form. See you tomorrow.